Hello, my name is Sven Sperling and I am a PhD student in the Mechanics of Materials research group. My project is concerned with the numerical modeling of wear particle detachment, specifically applied to silicon wafers. Silicon wafers serve as a base product for small-scale electronic products. A very important manufacturing step is the projection of a very small-scale pattern upon the silicon wafer using a so-called lithography module, which is depicted on the screen. However, contact between the silicon wafer and the machine part initiates a wear-like mechanism which can interfere with maintaining a fine projection resolution in two ways. One is that the damage which accumulates at the bottom can cause the wafer to tilt on the stage. And secondly, wear particles flowing around can interfere with the ultraviolet light. To investigate this contact between wafer and machine, we have to look at a place in the machine where contact is prominent. And from there we define a macro-scale situation, which is simply a wafer resting on 3 pins. If I zoom in on the pin in the wafer, I can obtain a so-called mesoscale contact situation, and I can see that the rough surface of this pin is indenting my silicon surface. This, in combination with small vibrations, can initiate fracture and eventually wear particle detachment. If I now look at a single asperity of this rough surface, I obtain a micro-scale situation. And this micro-scale situation coincides with the so-called single asperity model, in which we can perform scratch tests to investigate mechanisms that play a role in the formation of these wear particles. My PhD project is now concerned in translating this scratch model to a computational model, so that we can engage in predictive modeling